Hello. I want the class to be, very interactive. I don't want just me alone to be doing the talking. The only way you can understand this course properly is for us to have communication, not just me doing the talking.
Okay, can I try?
Yes, you can. Let's meet you first.
My name is Theodora Okafor.
Theodora Okafor, okay.
Yeah, and I think plumbing is the installation of pipes as a channel passage for water supply and the water-related waste to be taken, water taken into the compound, into the house, and water-related waste taken out of the house.
Okay, that's nice. That's nice. Okay, I've looked at it this way and I've come up with this definition. I said it is an act of bringing in water. This water could either be hot or cold water through pipes and fittings. The water will need to pass through pipes and fittings for use. You just don't bring in water for the sake of bringing in water. You bring in water for use. And the used water is taken out of the building through sanitary wares, pipes, and fittings with the aid of inspection chambers. I repeat, I said it's an act of bringing in water. This water could either be, in bracket, hot or cold, through pipes and fittings for use, and taken out after use, could either be waste water or soil, through sanitary fittings, pipes, and inspection chamber. I hope the definition is clear. Hello?
It is.
Hello?
It is
Yes, clear.
clear.
Yes.
Clear. Good. And so, now, how do we get water? What are the sources of water? What are the sources of water? Who can mention to us the source of water? Hello? Like I said, this class cannot be.
Hello, sir.
Hello, I can hear you.
My name is Daya Devi.
Taya Adegoke, okay.
Daya
Can you please mention
Devi.
to us source of water?
We have well water as a source of water.
Well, okay.
Yes. We have bowl as a source of water.
Good.
We have streams as a source of water.
Good.
That's all for now, sir.
Okay. Who else wants to try?
All right. Good afternoon, sir. Good afternoon, everyone. Yes.
Good afternoon.
I'm Ibukum by name.
Ibukum, okay, good.
Yeah, so well, just like my colleague has said, source of water, I believe, is either we are talking about borehole, which could be well or the regular one from to supply to feed the house like we are used in our environment here anyways. And then I believe it can also be from water bodies, which could be sea, ocean, stream, as the case may be. Then probably another source would be through condensation or rainfall, as the case may be.
Rainwater.
Yes.
Rainwater, good. All the sources you mentioned are actually the known source of water. For this class, we'll be looking at the borehole. And for the borehole, we have two types of borehole. We have the deep borehole and we have the shallow borehole. Now, basically the borehole, I'm going to mention what makes up the borehole. We have the external pipe, which is referred to as the casing. Then we have the riser pipe that takes the water from the borehole itself. That vertical pipe that comes from inside the casing outside is referred to as the riser pipe. Then, since we've mentioned that we have two types of borehole, the shallow and the deep borehole. The shallow borehole is within from 0 meter to 30 meter. It's referred to as a shallow borehole. Now, also, for us to get water from the borehole, we need what is called a pump. And basically, we have two types of pumps. We have what is called the surface pump and the submersible pump. For the shallow borehole, most times we use single phase pump, and that brings us to in terms of electrical, we have two types of motor, because the pump is attached. The pump is made up of two parts: the electrical parts and the mechanical parts. Now, for the electrical parts, we have two types of motor that's basically used for the pump. We have the single phase motor and we have the 3-phase motor. Now, the mechanical aspect of the pump, we have what is called the impeller. We have the water seal. Then we have the bearing. Then we have, at the outer part of it, we have the fan. Now, for the shallow borehole, most times we use single phase pumps ranging from 0.5 horsepower to 2 horsepower for the shallow borehole. For the shallow borehole, if we are going to use submersible pump are those pumps that you can actually put inside the well. That doesn't require, it only works inside the borehole. It cannot work outside the borehole. But for the surface pump, it works outside the borehole. And for you to take water from the shallow borehole using the surface pump, you also require to attach what is called the foot valve at the end of the riser pipe that goes into the borehole, the foot valve. Most times I advise people that even when you introduce the foot valve is a single directional valve. That is, it allows water to flow in one direction. I tell people that even when you install the foot valve, most times it could fail. So what you could also use in support of the foot valve is what we call the non-return valve. I hope I'm not too fast. Hello, class.
No, sir.
I hope I'm not too fast.
You're not, sir.
You're not.
Okay. So you attach the non-return valve after the foot valve, so that in case if the foot valve should fail, the non-return valve will serve as a backup. Now, in terms of maintaining a single phase pump, there are times you will install a single phase pump and you will discover that the pressure from the single phase pump drops. There are two things you need to look out for. It's like your normal ceiling fan. Most times you discover that the speed of the ceiling fan is no longer, as strong as it used to be. What could be the cause of that is the capacitor. The same thing applies to your single phase pump. When the pressure is not much, the pressure is no longer high, check the capacitor. It could be the result or the reason why you have low pressure. All you need to do is to tell your plumber to replace the capacitor with another capacitor. That will rectify that fault. Secondly, it could be that your foot valve has taken in maybe mud or dirt. So all you need to do is to advise the plumber to bring out the foot valve, clean the face, or the spring on the foot valve would have collapsed. Just change the foot valve and you will come back to the high pressure you used to have. Now, for a 3-phase pump, when the pressure for a 3-phase pump drops, that could only happen if the direction of rotation is wrong. Normally for a 3-phase pump, it's supposed to rotate clockwise. If it's going anti-clockwise, that means the pressure from that three-phase pump will be low. So all you need to do is to get your electrician and ask your electrician to reverse the phase. Once the phase is reversed, you go back to your normal high pressure. Question. Question. Okay,
All right, sir.
I'm with you.
Oh, yeah,
Do you have any question? Do you have any question?
Yes, sir.
Okay.
So what do you mean by three-phase pump? Does that mean the surface one can be three-phase and the bulk can be three-phase?
No, the surface pump can be three-phase or single-phase pump.
How about the one in the
You know, the surface pump, another name for the surface pump is called the centrifugal pump.
Yes.
Even your submersible pump comes both in single phase and three-phase.
Okay.
Have you done your electrical installation?
No.
Not yet.
No, sir.
But I hope you should know the meaning of what I mean by three-phase pump.
Yes.
Three-phase, you know what three-phase?
Yes, sir.
So I'm saying that the three-phase pump, for it to work, you need to supply that pump with three-phase for it to work.
Okay.
But for the single phase, it works with just single phase.
I get it, sir. Thank you.
Okay.
So sorry, as a follow-up to that question, sorry.
Yes, sir.
Does three-phase mean, for instance, if it's submersible, can the water supply 3 points at the same time? Is that what you mean by?
No. Three-phase that I mean in terms of electrical supply. Your power output.
Okay. So that is determined by the consumption of that pump, is it? The capacity.
See, on the pump, where you have the motor, like I told you, the pump is divided into two parts: the mechanical parts and the electrical parts.
Yeah.
The electrical part is where you have that coil with the stator. On top of that electrical part, you have like a small panel.
Okay.
When you open it, you discover that it has 3 legs.
Okay.
Now, for you to power that pump, you need to supply 3 phases to it. Maybe I should use a layman language, 3 cables.
Okay, that's better.
Is it clear? It's
Yes.
not the discharge. For the mechanical parts of the pump, that's where you have two intake. One intake and one discharge. What is known as the suction side and the discharge side, where it sucks from and where it will discharge from.
Okay.
Are you getting it?
Yeah.
Huh?
Yes.
Any other question? Is it clear?
Yes, sir. Yes.
Sorry, sir. I have a comment, please.
I have a question.
Yes.
Okay.
Sorry. Good evening, sir.
Evening.
Sorry, my name is Aditayo Adeleye. I have a comment. It's not. It's just a bit of correction. You said when you explain layman language, you mentioned that to connect 3 cables to it for 3-phase. Actually, 3-phase, you're going to be connecting 4 cables because of the neutral.
No, I know I know it's going to be there's neutral.
Now,
I'm only trying to make it simple.
Yes, sir. Yes, sir. All right. Thank you.
Any other question?
Yes, sir. I want to get something. It's something I didn't pick. You were talking about the 3-phase. Just you said when it's low, when the pressure is low. You mean I just want to get clear. We need to do phase reversal, right? Is that what you meant?
Yes.
Okay.
You just ask your electrician. Once you put on the pump.
Yes.
And you discover that the pressure from the pump is low.
It's low. Yes.
It means, well, you can even test it on ground before you lower your pump. If it is a submersible pump, you discover that the fan will be going you know that fan at the bottom of the pump will be
Yes,
rotating
yes.
anti-clockwise instead of clockwise.
Okay.
So
Okay.
all your electrician need to do is to reverse the phase.
Okay. Okay.
So once you reverse the phase, it will rotate clockwise and the pressure will increase.
Okay. Okay. I get that. So but if it's a single phase, then it's probably the capacitor
If
or
it's a single phase is the capacitor.
Okay. Or you said that something is clogged.
Or the foot valve. The
Non-return
foot
valve.
valve is at the bottom of the riser pipe.
Okay.
You know that pipe, that smaller diameter pipe that is inside the bigger diameter pipe.
Yeah.
The bigger diameter pipe is what we refer to as the casing. The smaller pipe that takes water from the borehole outside is what we call the riser pipe.
Okay. Okay.
So are you getting it?
Yes, sir, I do. So I think the last one is we talk about shallow borehole from 0 to 30 meters, right? So
yeah,
you normally use
then
a single phase pump of 0.5 to 2 horsepower.
0.5 to 2 horsepower.
Okay.
We work effectively for a shallow borehole. The
Okay.
reason is this, you know, the yield of a shallow borehole, when I say yield, the water you can get from the shallow borehole cannot be compared to the water you will get from a deep borehole. The yield from a deep borehole is more than the yield from a shallow borehole. If you overrate your pump for a shallow borehole, it will suck the water you have in the borehole and it might run dry and get the pump burnt.
Yeah, the pump. Okay. All right.
Are we communicating? So for a deep borehole, you cannot use a single phase pump. One, because of the depth of the borehole, the single phase pump will not be able to suck water and supply. Because, for instance, rule of the thumb, for a 1 horsepower pump, it can do just 10 meters. And a deep borehole is from 30 meters and above. So if you use a 1 horsepower pump, it will be able to suck water from the borehole and supply. So you require a bigger capacity pump from 3 horsepower upward. And from 3 horsepower upward, they always come in what? 3 phase. Am I communicating? Is it clear?
Yes, sir.
Like I said, the class should be very interactive. That is the only way you understand what I'm saying. You ask questions. Don't allow me to do the talking alone. Ask questions.
Yes.
Understand? If you're not clear, you ask your questions. You've paid your money.
Is that, if you can allow what you are trying to explain to be displayed on the screen, the way what is displayed is different from what you're explaining is kind of a little complicated at times.
Said?
I'm trying to say when you try and make it that what you're explaining is same as what you are displaying on the screen, so that we can follow better like that.
Okay, let me just say something before I continue. You see, most times I don't use the slide because I say things that are not in the slide that I will need you to do.
Okay, in that way, so we can know we are not following the slides then.
There are things that are not in the slide I will need you to know. It will make the class very easy and very understandable for you.
Okay. All right then.
So that when we go on the road trip, you can now bring out your notes that you've taken and ask those questions that you feel you did not get from the slide and I will explain to you. Practical.
All right, that's okay.
Somebody is making noise at the background. Okay, another question. Can I continue? Hello?
Yes, sir, you can continue.
Okay, we've talked about the borehole. So, you know, after the borehole, we can't just supply the water from the borehole into the building. No, the water, we need to treat this water before we supply this water into the building. So that will take us into the water treatment plant. Now we have two options of treating water. We have the chemical option. Then we also have the reverse osmosis option. Now, for the chemical option, before you treat any water, I repeat, before you treat any water, you need to take a sample of the water from the borehole that you've drilled to the lab where analysis is done, water analysis is done, to determine three things. One, the physical analysis of the water is done. And the physical analysis of the water that is done, what is determined is this. Does the water have color? Does it smell? Does it have taste? What is the temperature of the water? Two, chemical analysis is done. Does the water contain iron? And this one, we are, in terms of iron, we're looking at two types of iron. Iron 2 oxide and iron 3 oxide. What is the pH of the water? What is the TDS of the water? TDS simply means total dissolved solid. Does the water contain salt? Salinity test. These are some of the things that the analysis, the analyst we need to check for us. Then 3, biological tests. Does the water contain germ? Does water contain bacteria? Now, after the analyst has done his own analysis to determine these 3 options, with this, we now know the kind of treatment we are going to give to the water. Basically, we have about 4 or 5 chemicals that is used in treating water. One, we have the chlorine. And for chlorine comes in 3 different forms. We have the tablet chlorine, we have the powder chlorine, then we have the liquid chlorine. Please, if I'm too fast, you let me know. I hope you are getting it.
Yes, sir. You are okay.
Okay.
Yes, sir.
Then 2, we also have what is called soda ash. 3, we have what is called lime box. 4, we have caustic soda. 5, we have alum. These 5 chemicals are used to treat water, depending on the analysis that the analyst has given to us. Now, for water to be treated, one of the first things that you need to know is the pH of the water. The pH of the water. The pH basically is like a rule. It's labeled from 1 to 14. At the middle is 7. From 0 to 7 is acidic. Then from 7.1, sorry, from 0 to 6.9 is acidic. 7 is referred to as neutral. Then from 7.1 to 14 is basic or alkaline. Now, who can tell us, you've mentioned chlorine. Who can tell us the function of chlorine in water? We are all facility managers, I believe. So we should know the function of chlorine in water. What is the function of chlorine in water? Hello?
To remove
Hello?
every smell in the water.
Huh?
To remove any form of smell in the water, odor
Chlorine.
from the water.
Chlorine basically does not remove smell. It will only reduce the smell. It doesn't remove the smell.
Okay. It will neutralize any microbial agent. Let me use that word, agent.
That's good.
That is to kill. That is to kill germs.
Kill germs. Yes, you're right.
Yes.
It also aids in purification in terms of the color of the water. Chlorine is a bleaching agent. Chlorine is a bleaching agent. It also helps, to give you, to improve the color of the water. Now, chlorine can never react in water if, before I go further, let me mention this. The WHO standard, allowable standard in terms of pH value for water is between 6.5 to 8.5. Your water can be said to be clean if the pH value is between 6.5 to 8.5. If you get 7, fantastic. 7 is neutral. 6.5 still contains a little bit of acid in the water. Then 7.1 to 8.5, your water is, the alkalinity level in your water is a bit high, but it's still allowable. WHO standard is allowable. But chlorine will not react in water if the pH value of that water is below 5.5. You need to note that value. Chlorine will not react in water if the pH value of that water is below 5.5. So if my pH value in the water is 5.5, how do I improve it? Come in. How do I improve this value? I've mentioned to you that we have what is called soda ash and we have what is called lime box. If your pH value is below 5.5, there is need for you to increase the pH value. And you can only increase the pH value by introduction of soda ash. Soda ash will increase your pH value. Now, if your pH value is above 8.5, you need to bring it down. You can only do this by the introduction of your lime box. Lime. Are we communicating here? Please, these are key factors that determine what that will aid you when you're treating your water. Those 3 points I've mentioned are very key when treating your water. I said chlorine will not react in water if your pH value is below 5.5. Chlorine will never react in water. Now, and I'm giving you the standard allowable value for your pH value in water. I said between 6.5 and 8.5 is WHO standard. If the pH value is below 5.5, for you to boost the pH value, you need to introduce soda ash. And if the pH value lime or lime box. Is it clear? Is it clear?
It's clear, sir.
You guys should respond.
Yes.
I don't want to feel alone.
It's clear, sir.
We all put our mics on it to be how that's why we are.
You said what?
We can't all have our mics on. That is why you don't hear us. And will be.
Okay, okay, but at least once in a while, you guys should respond. I beg. If not, I'll think I'm talking to myself.
Yeah, we can't
Okay, then the alum. Alum basically is used for coagulation. There are times use alum into that muddy water. What you observe is that it will pull the mud to the bottom while leaving the purer water at the surface. That's the function of the alum. So with this understanding, we will need to talk about the flow. The flow. Now, water is taken from your borehole through the riser pipe into a tank, the first tank, that is referred to as the aeration tank. Aeration tank. Aeration basically is just the breaking down of we allow air from the tank, air to react with the water to break down the ion content. So the ion content is broken down into smaller particles, so it can settle at the bottom while you leave the cleaner water on top of the surface of the tank. Now, for the aeration tank, the standard aeration tank is supposed to be divided into 3 compartments. The first compartment, we normally refer to it as the sedimentation compartment. The middle compartment, we refer to it as the fluctuation or coagulation compartment, while the final compartment is referred to as the filtration compartment. I take it again. The aeration tank is divided into 3 compartments. The first compartment is referred to as the sedimentation compartment. The second compartment, we refer to it as either the fluctuation or coagulation compartment, while the third compartment is referred to as the filtration compartment. Now, the riser pipe that comes from the borehole, that is piped into the aeration tank. On top of that pipe, we introduce what is referred to as the aerator. And we have 3 types of aerator. We have what is called the sprinkler system. The sprinkler system is whereby, yeah? Someone want to ask a question? Hello? Somebody wants to ask a question. Can I continue?
Yes, please continue.
Okay. Now I said we have 3 types of aerator. The first one is referred to as the sprinkler type of aerator. This one, you have the water coming out in shower form. This type of sprinkler system, you have the water coming out in shower form. What the engineer will simply do is this: he either uses a pipe and perforate that pipe so that the water does not flow in jets, but it comes in sprinkler form, or it will make use of what is called your shower rose, the one you use in your bedroom. All it's trying to do is to break the ion content inside that water further, so that air, the surrounding air, can react with it and break the ion content further. We also have what is called a cascade form of aerator. For the cascade form of aerator, the water water from the borehole will be like form, your staircase. So it will flow from one step to another step, just like that. All they're not trying to do is to break down the ion content. Then the third one is the first fan. This type of aerator involves you introducing first fan by the side of a circular tank. All these are done just to break down the ion content. Now, if you don't use the natural air, you can equally introduce your air compressor or your blower.
How you spell the first fan?
You said?
Spell the first fan. Let's know what.
F-O-R-C-E-D. Then fan.
Okay, all right.
So on that, your riser pipe. Okay. Now, because we are using the chemical system, we have what is called the chemical tanks, where the chemicals that you want to inject into the water are introduced. On top of this chemical tank, we have a pump that is referred to as the dosing pump. The dosing pump. The dosing pump, the function of the dosing pump is to suck the chemical and inject it into the water. Because I've mentioned earlier on to you that chlorine will not react in any water that its pH level is less than 4.5. What we normally do is this: when we determine the pH value of that water, we ensure that if it is higher than 5, I mean it's lesser than 5.5, we attach the hose to the riser pipe. So before the chlorine is injected into the water in the aeration tank, if the pH is less than 5.5, your soda ash would have reacted with water so that chlorine can react effectively with water. If it's less than 5, if it's more than 8.5, your alum, your lime would have reacted with water so that your chlorine can be effective in the water. Because the first compartment is where you introduce your chemical. And the way it is divided, the way the aeration tank is divided, it is divided in such a way that the second compartment division is higher than the third compartment division. So that the clean water at the top will just flow in cascade form through the second compartment to the third compartment, where you have the filtration. The filtered water, the cleaner water. Now, a lot of people, the mistake they do is this: after having their dosing pump on top of the chemical tank, they just leave it like that. Most of these chemicals, they come in powdery form. If the analyst or the chemist has advised you that you need to inject, for instance, if it is powder chlorine or soda ash, that you need to inject 4 grams of chlorine, that you require 4 grams of chlorine to liberate 1,000 liters of water. Because the chlorine you are injecting in this water is powder form, you will require what is called a stirrer to continue, stirring this chemical so that you have homogeneous mix, so that the exact 4 grams of chlorine that has been advised by the chemist to liberate 1,000 liters of water is what you are actually injecting into the aeration tank to have effective treatment. Because most times people will say, the chemist said I should use 4 grams of chlorine, and I'm using 4 grams of chlorine, but I'm not getting clean water. No. When you pour the 4 grams of chlorine into your chemical tank, the first time you did it, maybe you just used 1 pipe or 1 stick to stir the mix, and you achieve that homogeneous mix. And there is no stirrer to allow for that continuous mix, so that you have that homogeneous, mix and that 4 grams that you're expected to inject into the 1,000 liters of water is being achieved. It's like your powder milk. If you put your powder milk inside water and you not stir continuously, some part of that powder milk will do what? Settle at the bottom of the water. Effectively, the 4 grams is not what you are injecting to the water. Maybe what you end up injecting to the water is 3 grams. So you will not be able to treat the water effectively as you've been advised by the chemist. Am I making sense here? Hello?
Yes,
Yes, sir. Yes, right.
Are we communicating?
Very well, sir.
Yes, sir.
Okay. You should ask question now if I continue.
Okay, I wanted to ask, you said when what's it called now? Sorry, hold on, let me see where I wrote it. Okay, when the acid in the water is less than 5.5, you said we should not use.
I didn't say acid, I said the pH.
Sorry, pH in the water is less than 5.5. You said we should introduce soda ash, right?
Yes, to increase the pH level.
Are we?
So that the chlorine be able to react to the water.
Oh, okay. So we are not. We will add it to the chlorine. Not that we are not. We are taking out the chlorine.
No, you see, before the chlorine reacts with the water, you need to introduce your soda ash to boost the pH of the water to an acceptable level that the chlorine will be able to react with it. Because if the pH, excuse me, if the pH of the water is less than 5.5, chlorine will not be able to react with the water to give you a desired result. So for you to get your desired result, you need to boost the water by introducing soda ash.
Okay, so we use
so the pH level of the water is increased to above 5.5.
Okay, all right, that's clear. Thanks.
I hope it's clear enough.
Yes, it is. Thank you.
Hello, sir.
Hello, I'm with you.
Yes, my question, how do we know the pH of value in the water?
Okay, there's a pH meter. A pH meter that's used to test the pH of the water. We have the digital type and we have the manual type.
So what we do is we just take a water and keep it inside, or
no, you can do it. You can even do it on your site. Buy the pH meter, it's not expensive. We have the one that is sold for 13,000, 14,000 that does, I'm sorry, 15,000 that does pH alone. But we have the one that do 5-in-1. Like we sell as well.
Okay. That will help us to know the pH value. And
yeah, just take a sample of water from the borehole directly, dip the pH meter into it. It should just display digital to tell you your pH is 5.5, your pH is 7, your pH from 0 to, like I said, 0 to 14 to tell you the range of the pH in the water.
Okay. Thank you.
Hello.
Yeah, I'm with you.
Okay. I don't know. I was having a network.
So let me always put a name to the.
Okay. Okay, I'm Daniel.
We'll put the name to the
okay,
voice.
Let me just. Okay, I'm Daniel.
Okay.
Daniel Adoko. I'm actually. I don't know. A call came in when you were talking about adding soda ash and all the the chlorine. I don't know whether you also have you talked about the basic, if the water is basic. I don't know whether you.
Yeah, we've mentioned that.
Explained that. Yeah, I mentioned that already.
I said to you, we mentioned that the first thing you do before you treat any water is to know the pH value.
Yes.
Now the pH value is like a ruler from 0 to 14. I said from 0 to 6.9 is acidic.
Yes.
7 is neutral. Yeah. And 7.1 to 14 is your alkalinity level or your basic level.
Yes.
And I also said we have some chemicals that we use to treat water, which I mentioned: chlorine, alum, soda ash, lime, caustic soda. And I said to you that for chlorine to be effective in any treatment you are doing, if the pH value is less than 5.5, chlorine will not react with that water. So you will need to increase the pH value to the standard. WHO standard is between 6.5 to 8.5. Now, how do you increase the pH value from a lower value to the acceptable value? By introducing soda ash. If the pH value is more than 8.5, then you need to bring it down. How do you bring down this pH value to acceptable value of 8.5 to 6.5? By introducing lime to it.
Thank you, sir. I'm clear. Thank you, sir.
Any other question? Questions?
So, hello, sir. Sorry to draw a little bit back. I just want to get, you said we had lime to do what? I didn't get that clearly.
We add lime to reduce the pH value.
Okay, to reduce. Okay, great. All right, thank you.
Can I continue? If there's no question,
yes.
We'll continue. Now, from the filtration stage, which is the third compartment of the aeration tank, we introduce a surface pump. Now, the surface pump will take the water from that filtration compartment and it will pass it through what is called the filter vessels. We have different types of materials these days that we use in fabricating the filter vessels. We have filter vessels that are made from fiberglass. We also have filter vessels that are made from stainless steel. And we have the third one, filter vessels that are made from mild steel. Now, inside the filter vessel.
Hello, sir.
Hello.
This slide is not corresponding with the audio. I don't know. Is it different from?
I've explained earlier on that if you want me to follow the slide, some of these things I mentioned are not in the slide.
Okay. Just
you need to get.
I didn't join early. That's all.
Okay. So I said to them that when we get, when we go for road, the
workshop,
road trip, you're going to ask questions deeper.
All right.
Plumbing basically is a practical class.
Exactly.
It's a practical class. So like what I used to say, what I did in school for 5 years, you want to just grab the learning in 3 hours. So you need to allow me to quickly run through the 5 years course in 3 hours. So I will just give you the key points. You understand? Hello?
Yes, I'm with you, sir.
Okay. So I said the filter vessel, basically we have 3 types. The one made from fiberglass, the one from stainless steel, and one from mild steel. Now, inside this filter vessel, we have some things inside this filter vessel, and they are referred to as media. M-E-D-I-A. Media. Now, for the first filter vessel, we don't say we load the filter vessel. The right word for it is that we recharge the filter vessel. The first filter vessel is charged with what is called the sand media. The second filter vessel is recharged with what is called activated carbon. Now, for the sand media, we have 4 different types of media that's always charged with the first filter vessel. We have what is called the big stone. And these stones are in aggregates. When I say aggregate, they are in different diameters. as advised by the analyst. We also have what is called the small stone. Then the third layer is filled up with what's called coarse sand. The final layer is the charged with what is called the smooth sand. Now for the second filter, the agitated carbon. We have two types of agitated carbon. We have carbon that is made from wood. Then carbon that is made from coconut shell. The most effective of the two is carbon gotten from coconut shell. The reason is because the absorption rate of coconut carbon, it's faster than that of the wood, and it's more reliable. Now, depending on kind of the nature of the water you are treating, we also have what is referred to as BIRM, B-I-R-M. BIRM is used basically to remove the iron in the water. Because even after your aeration and everything, some iron will still escape and pass through this filter. It is the function of the BIRM to trap that iron.
So please, can you...
Also, we have another media that's referred to as the adolite. The function of the adolite is basically to improve the texture and, if I'm permitted to use this word, improve the texture and the, will I say, fineness of the water. That's the color of the water, to make it even more, crystalline. That's the function of the adolite. Then again, some of the water that we treat, we discover that there's a need for you to introduce what is called resins. And we have two types of resin. We have the positive charge resin and we have the negative charge resin. This again is also determined by either the engineer or the water analyst that will tell you when to use the resins. Are you communicating? Now, for the carbon, basically the function of the carbon is to take care of the odor, take care of the taste, to improve the taste, and also the color of the water. Resins basically is to do with the iron, the salt content. Salt content in the water. But the truth is this: when you have salty water, the best and the most reliable way of treating water that has salt is the use of the second option of treating water, which is the reverse osmosis plant. Now, if we remember those days in secondary school, when we were doing biology, our biology teacher will always ask us, what is osmosis? And today I'm going to ask the class too, what is osmosis? I'm listening. Anybody?
Yes, sir.
Okay.
Osmosis is the movement of liquid molecules from a region of lower, region of a lower, I forgot to the higher.
Hey, you forgot your biology.
Hello.
Yes, sir.
Okay. I think it's the movement of molecules, which could be gaseous or liquid, from a lower
concentration to the higher concentration.
That definition is not complete. Who else wants to try?
Hello. I'd like to try, Peter.
Yes, you can.
Okay. So osmosis is the movement of molecules, water molecules mostly, from a region of lower concentration to a region of higher concentration through a semi-membrane.
Very good. Very good. Your definition of osmosis can be complete without membrane. So basically, it's the membrane that does the function of that osmosis. We've said is the movement of water molecule from a region of lower concentration to a region of higher concentration through a semi-permeable membrane. So what we've done here is we've reversed the process. We've reversed the process. Now, the reverse osmosis is basically the movement of water now from a region of higher concentration to a region of lower concentration through that same semi-permeable membrane. So the way the reverse osmosis works basically is this. It works in two forms. We have the reject water and we have the clean water. So as water is pumped through the membrane by a higher pressure, it is forced to pass through that membrane by a higher pressure. It will reject the dirty water, what we call the reject water. And when it passes through that membrane, it will now give you the cleaner water. And as of today, it doesn't use any chemical. Rather, it just uses that membrane. And as of today, the reverse osmosis plant is the surest form of treating water. Because one, you don't need to inject chlorine, you don't need to inject any form of chemical. And the purity level of you using the reverse osmosis plant is 99.9% pure than the chemical treated water. I hope I'm making sense here. Now, after the filter vessel, some designs will decide to use what is called a UV, ultraviolet ray, in case if all the chemicals you've injected, some of the germs still find their way to a UV, uses high ray bulb, it will do what? It will kill the germ. From there, water is now taken to what is called the UT tank, that is underground tank, or the surface tank. And if from the surface tank, you now introduce a pump that takes the water to the overhead tank. And this now brings us to distribution of water into a building or into an estate. Distribution of water into a building or into an estate. Now, we have two types of supply of water into a building or into an estate. One is by gravity. Then the second one is by booster system. Booster system, which just refers to use of a hydro-pneumatic system. Hydro-pneumatic system. For the gravity system, the water is pumped to the overhead tank. From the overhead tank, by gravity, it discharges to the various buildings in the estate, or if it's a private residence, it discharges to the various bathrooms in the building. And this, the advantage of this is this. once you've pumped water to the right tank, whether there is power or there is no power, you get, water is supplied to the building. But the second system that uses the booster system, this is achieved through what? Pumps. Through booster pumps. The pumps, you need power to supply water 24/7. Once there's no power, there's no water in the building. There's no water in the estate. The other disadvantage of the booster system is this: if your pipes are not adequately sized, because of the pressure from the pump, you could be experiencing burst pipe along the line. So most times we advise that the gravity system is better because the cost of maintenance for gravity system is low. The only disadvantage of the gravity system is that the CapEx, which is the initial expenditure, that's the capital expenditure, is high. But the OpEx, which is the operating expenditure, is low. Maintenance for gravity system is very minimal. But for the pump, maintenance is high because it's working continuously. So the lifespan is reduced. I hope I'm communicating. The class is silent again. Oh.
Yes,
Yes,
sir.
Question.
I listened to the explanation, sir. But please, the osmosis of a thing, can you communicate that?
The reverse osmosis of a thing.
Yes.
Okay, basically it's reverse osmosis. It uses two pumps. The high pressure pump and a low pressure pump. Like we've defined it. We've said osmosis is the movement of molecule from a region of lower concentration towards higher concentration through a semi-permeable membrane. And from the term, we've said reverse osmosis plant. So it's not the movement of water from a region of higher concentration to a region of lower concentration through a semi-permeable membrane. So this time around, we have a vertical pump which serves as the higher, concentration. It now pass through that membrane by virtue of the lower pump. So what that membrane does is that if there is any salt in the water, it will reject it. It works in two ways. The way it is connected, you will see the reject water being displaced and the clean water being taken to the clean water tank. Is it clear?
Yes, sir. Thank you, sir.
You will get it better when we go on the road trip.
Okay.
We'll demonstrate it for you and you see it. Any other question? Now, after the water is treated and is taken to the barrier tank or to the booster system, this water is now supplied into the building. Now, for the building, we have two types of piping system. We have what is referred to as the conduit piping, and we also have what is referred to as what? The surface piping. Now there is need for us to determine the types of pipes that are used because we are still talking about cold water system. Types of pipes that are used for cold water system. We have what is called the UPVC pipe. And the full meaning of UPVC is on plasticide polyvinyl chloride. We also have what is called the PVC pipe, which is polyvinyl chloride. We have what is called multi-layer pipes. We have the copper pipes. We have the stainless pipe. We have the mild steel pipe. We have what is called, we call the PPR pipe. Now also, we're looking at these pipes. How do we connect them? That is talking about fittings. we have different types of fittings. We have the elbow. For the elbow, we have the 45-degree elbow. We have the 90-degree elbow. We have what is called the T. We have what is called the reducer, or what the plumbers will call bushing. We have the adapter. We have the nipple. We have the union connector. We have the white T. We have the plug. I hope you guys are writing this down. Hello?
Yes, sir.
Okay. Mention 6 types of fittings that I've just mentioned now that you can remember. 6.
45 degree,
Okay.
90 degree,
Okay.
reducer, adapter,
Okay.
nipple,
Okay.
union.
Union. Good.
Connector.
Eh? Hello.
Connector.
Connector.
Yes, connector.
Yeah.
Union connector.
You mentioned union connector. Somebody is saying connector.
No, union
Is it
connector.
called connector?
No, somebody say union, and I say union
Union is
connector.
right. Union connector is right.
That's what I said.
Okay. So
There's
we need to understand.
elbow.
Yes, she has mentioned elbow, and she mentioned the 2 types of elbow: the 90-degree and the 45-degree.
But how about those inch pipe?
You said
Those inch connectors.
those
Inch connectors.
inch.
Because I had the supervision on site that they use 1.5 inch connector type of thing.
Those are sizes,
Pipe.
sizes of
There you
material
go.
and sizes of pipes. I was just about to go into that now. We have different sizes of pipes and different sizes of fittings. Now we have what is called the SI unit, and we have the imperial unit. The imperial unit is what you call inches, pound, feet, yard. All those are imperial units. The SI units are in meters. Now, the half-inch pipe or half-inch fitting is equivalent to your 13 mm fitting. The 3/4 inch is equivalent to your 19 mm. Your 1 inch is equivalent to your 25 mm. Your inch and quarter is equivalent to your 32 mm. Your inch and half is equivalent to 40 mm. So you can do the mathematics of the rest. Now, there are different forms of joining these pipes. We have the threaded forms, pipes that come in thread. And for you to join those ones together, you also require threaded fittings. We have those that are plain that you need to use gum to join the fittings to the pipes together. Then we also have the ones that you need heat, like your PPR pipe. You require heating machine. You increase the temperature of the fittings, increase the temperature of the pipe, bring them together, they form a bond. Then you also have the one you use your welding machine, like your stainless pipes and your galvanized pipe and your mild steel pipe. You require the welding machine to join them together. Though some of the stainless pipes, they also come in thread. Also, you have the ones that you just use, the multi-layer pipes. They have 2 types. There are some you use clamp, you just clamp them together, and there are some you use your spanner to join them together. You also have the one that you use your copper pipes. Those ones you use C-force and gas to do what is called brazing. C-force, gas, and their lead carry out what's called brazing. I hope we are getting it. Now, when do we use these fittings? The elbow basically is used when you want to negotiate a bend or a corner. You introduce the elbow. When you're running your pipes, for instance, you know your WC cannot be at the same, where you have the WC might be different from the same wall where you have your wash hand basin. Now, for you to negotiate that bend to link the pipe from the WC to the wash hand basin, the wall that is carrying the wash hand basin, you use what is called an elbow to achieve that. Now, there's every tendency that you might have your wash hand basin on the same wall where you have your wash hand basin, your WC on the same wall where you have your wash hand basin. For you to achieve such connection, you'll use what is called the T. The T. If, for instance, I'm doing my piping with a 1-inch pipe, which is also a 25 mm pipe, and I decide to reduce from 1 inch to 3/4, the fittings I will need to introduce is the reducer, or what the plumbers refer to as the bushing. So I will use a reducer that is from 1 inch to 3/4 to achieve that reduction. Are we communicating? Is it clear? Is it clear?
Yes, sir. Yes, sir.
Okay. Also, we have what is called the online valves and the inline valves. Online valves and the inline valves. I think you can see that one on your slide. You can see down on your slide. I don't need to mention a lot about that one. You can read that one up on your slide. We have, for instance, we have the gate valve. We have the butterfly valve. We have the non-return valves. That you can see on your, you have the globe valve. Now, of time, let's look at waste. Waste. Before we look at the waste, there's something we need to discuss that is very, very important. And that is called traps. Traps. Let me first of all start. Yeah. Sorry. Okay. What's up? I said what's up.
Hello, sir. Hello, sir.
Sorry, I'm coming, please. Okay, sorry. I'm talking about traps. Now we have what is called the P traps, the S trap, the U trap, the bottle trap. I will explain all.
Sorry, sir, the trap you're talking about, do you mean CRAPS?
CRAPS, yes, traps.
Okay.
Now you see, let me start with your WC. For the WC, we have basically two types of WC. We have the one with a P trap and we have the one with the S trap. Now, for the S trap, the S trap WC is used on the ground floor. A lot of plumbers don't know that. They go to the market and they'll buy WC for you. They don't check if it's a P trap WC, if it's a S trap WC. If you use the S trap WC in first floor, you'll be having frequent blockage. The P trap WC is supposed to be used in first floor and above. The S trap is basically for the ground floor. P trap is for first floor and above. Now, what is the function of the trap? Why? Have you ever asked yourself this question? Why is that when you flush your WC system, you still have water inside the bowl? Do you know why?
No.
Okay.
No, sir.
Like I said, the WC has two types of trap, the P trap and the S trap. The water inside the bowl is the reason why you don't have odor returning into your toilet. That's
to trap the smell.
It traps the smell.
To trap the smell.
Said what?
You have to trap the smell.
Exactly.
To trap the smell. Yeah.
To trap the odor from coming back into the toilet. That is the function of your trap. Once you don't have the trap, for instance, your kitchen sink, under your kitchen sink, what you have is referred to as a bottle trap. The bottle trap. Your bathtub, your shower tray, the kind of trap you have there is called the P trap. The function basically is to trap odor from returning from the inspection chamber into the toilet. So most times, if you don't have this trap installed, you are bound to have odor. Now, let me share one small experience I had. I actually did a building, one of these high-rise building. I happened to be the project manager of the building then. We had to do like a revamp of the entire building. And the bank MD traveled out, came back after 2 weeks, and the whole of his toilet was stinking. So they invited a plumber, to rectify the fault. The plumber came in, he could not, chisel the wall, trying to see if there's any leakage from the waste line. There's no leakage. Did all he could do, he did not achieve. We was unable to take care of eliminate the odor from the toilet. So it was the bank MD's driver that I said, but there's an engineer in this building that are doing renovation work. Invite the man and let him come and see if he can, rectify this issue. So I was invited. I got to the MD's toilet and I said to them, okay, you guys will pay me 50,000 naira. I'm talking about 2005. I'm going to, eliminate the order for you guys, but you pay me 50,000 naira. You give me 25,000 naira first, then 25,000 naira after the job is done. They accepted. And I said to them, okay, for me to do this work, all of you will leave the toilets I want to be left alone inside the toilet. They were like, the enemy's toilet. We can't leave you alone inside the toilet. I said, no. Your own is for me to, eliminate the odor. That is your own concern. After much, argument, the driver said, leave this man, let him eliminate the odor. So they left. I asked all of my technicians to just get me a camphor. What was the issue? The floor drain. Your floor drain has a trap. Normally, there should be water left in the floor drain. There was no water inside the floor drain. So the odor from the pipes, because it's a high-rise building, when they flush from other floor, the odor, because there's no trap on the floor drain, the odor was now expressing itself through the floor drain. All I did was just to get buckets, start flushing that floor drain. Use the towel. After flushing for like 30 minutes, just get camphor, put a little water inside the floor drain, then put a camphor, and that was all I did, and I made 50,000 naira. So when the guy came, he was like, no, we won't pay you. What did you do? I said to him, there's a difference between wisdom, knowledge, and you using your strength to achieve results. The driver said to them, this man has resolved the problem. Pay him his money. So what I'm trying to say is this: most of the challenge we have in our bathrooms, most of the other challenge we have in our bathrooms is a result of what? Traps. When you abandon a bathroom that for 1 week or 2 weeks without water flowing through those traps and water being retained in those traps, you are bound to have return of odor from your special chambers. Secondly, also, how do we eliminate this odor? Now, we have what is known as the vent pipe. The vent pipe. I said to you that vertical pipe for water line is referred to as riser pipe, isn't it? Hello? Hello? Hello?
Hi.
Hi.
Okay, for water line, the vertical pipe is referred to as riser pipe. But for waste line, the vertical pipe is referred to as stack. For waste line, the vertical pipe is referred to as stack. And so we have, if your stack pipe, the final stage of a stack pipe is at the middle of your window level for your toilet or bathroom, the odor when you flush is bound to return because normally air is lighter. So when you flush, it's better that the air will transfer, will flow from the bottom to the top to the atmosphere. But when you flush and the tip of that pipe is in between your window, the foul air will return back into your bathroom. So for proper piping, it is compulsory that your stack pipe is at least 0.5 meter higher than the final top of your window. Your window sill. The stack pipe should be 0.5 higher than it. Are we getting it? Hello? Hello?
Yes, sir.
Yes, sir, we're getting it.
Okay. Now, we have 3 types of stacking system. 3 types. Or 3 types of vent pipe. We have the single venting system. We have the combined venting system. Then we have this separate venting system. Now, for the single type of venting system, this is a system whereby you have both your waste from the WC, your waste from the wash hand basin, your waste from the floor drain, your waste from your bidet, from your bidet connected to a single pipe. If this is not properly done, if it's not properly spaced, when you flush, there's every tendency that the foul odor from WC will pass through the waste pipe that is joining from the wash hand basin to return the foul odor back to it. Though this single system basically is not even being used now, because those experienced plumbers, you can only find them to achieve this. Now for the combined system, even though it's separate, you have the pipe for the WC that will take all the waste from the WC. You have the pipe that will take all the waste from the wash basin, and the waste from the bathtub or shower tray, a bathtub or shower. But at the end of the day, at the top of it, the vent is linked to the bigger diameter pipe. Are you getting it? Are you getting it? For the separate system, you have separate venting system. The vent for the WC is separate. The vent for the wash hand basin and that of the bathtub is separate. They are not combined. Now, after running this vertical pipe that I refer to as stack pipe, by the side of the wall, because you cannot connect from one WC to another WC using elbow. No. Water line, you use elbow when you want to achieve a bend. But for WC, for wastewater, for you to achieve a bend, you don't use elbow. To achieve a bend for the waste or soil system, you use what is called the inspection chamber. You use one inspection chamber to the other inspection chamber to achieve your bend. Are you getting it? Hello?
Yes, sir.
Yes, sir.
To achieve your bend. Then, if it's an estate, from the inspection chamber, you now connect to what is called a manhole. Connect to what is called a central manhole. It's from the manhole that is what the water is now taken to the sewage treatment plants. Now, how does the sewage treatment plant work? Basically, like water treatment plants, the principle of the sewage treatment plant is not different from the water treatment plant per se. They have the same principle. The sewage treatment plant has three basic treatment stages. We have what is called the primary treatment. We have what is called the secondary treatment. And we have what is called the tertiary treatment. Now for the sewage plants. For the primary treatment, let me start with this your manhole. Some manhole, from manhole to manhole, some manhole flows with the help of proper gradients. If the gradient is okay, you have good flow before it gets to the sewage treatment plant. But there are some estates that you have issues with gradients. Those type of estate, they introduce what is called pumps, lift pumps, that will assist the sewage from being pumped from one station to another station before it gets to the sewage treatment plant. Because if the slope and the flow is not proper, you have what is called a back siphonage. That is where you have chambers getting filled up and overflowing, messing up the environment. You enter to some estates, discover that the manhole is overflowing. They will tell you it's blockage. At most times, it's not even blockage. Most times, it's as a result of the slope of the pipe not being correct. One thing some plumbers don't understand is this: you don't require a sharp slope when you are laying your waste pipe. You don't. The slope needs to be very, very gentle, very, very minimal, because when you flush, you require the pressure from the water to be able to push what you have along the pipe. So that can only happen if the slope of the pipe is gentle. If the slope of the pipe is sharp, you just have what you just do is that you see water will just flow by without pushing what the water needs to push. Also, because of the ladies, the ladies, because the sanitary pads they use, there are some sewage treatment plant that you need to, along the line, you need to introduce what is called shredder. So it will shred the pads into pieces. That is why for the sewage treatment plant, the first stage of the sewage treatment plant, we have what is called a screen there. The function of the screen is actually to trap things like towel, maybe leaves, maybe pads that are not shredded properly. The function of the screen is to trap it so that it's not cause blockage along the line. Are you getting it? Hello? Hello?
Yes, sir.
We are with you. Sir.
We are with you.
You said?
We are with you, sir.
Okay, let's ask questions. Try continue. Ask your question. Ask your questions. Or hello? Hello?
Yes, sir.
Ask your question, please.
Hello, sir.
Hello?
Yeah, sorry. Thanks for what you've been doing for the time now. When you're talking about the purpose of elbow, the T, you said the T is used when wash hand bathing. Sorry, I didn't really get what you said.
I didn't get that question.
The fittings, when you're talking about the fittings.
Fittings, okay.
We say elbow, we have 45 degree, 90 degree, then we have the T, we have the union, all those ones. So when you're now explaining the importance and the uses of these fittings, talked about that elbow is for to negotiate a bend or a corner. Then the T is used. I didn't get that very well.
You didn't get where the T is used.
Yeah, the T, you said it's used for, I didn't get to put something down.
The T is used when you want to connect two appliances on the same wall. The same wall. For instance, if I have my WC on the same wall with my wash and basin, you know, when I connect the water from the duct, it will pass through the wash and basin and the WC. From the WC, there should be continuation. That's what I'm trying to say. There should be continuation. The continuation, the T will aid the continuation. You're not getting it?
I've gotten it, sir. Thank you.
Yeah?
I say I've gotten it, sir. Thanks.
Okay. Another question? Question, please. Question.
Maybe there are no questions.
Yes, continue, sir.
Okay. So the primary sewage treatment plant, like I was saying, is the first stage. So you have the screen. The screen will take care of any bigger debt from the sewer line. Then after the primary treatment, the next stage is the secondary treatment. Basically, the primary treatment does not do much. If let's say if we are to score the treatment process 100%, the primary treatment basically does about 15 to 25% treatment. The main treatment happens at the secondary stage. At secondary stage, you have the sedimentation tank. And that sedimentation tank is where you introduce the, because what you are trying to achieve, for instance, if Lagos people are coming to look at your sewage treatment plant, some of the parameters they look out for from your effluent water, as it's referred to, is the BOD. The BOD is the biochemical oxygen demand. Is it okay? Then they look out for the COD as well. The COD is the chemical oxygen demand. They also look at your pH. They look at your pH. They also look at your TDS, total dissolved solid. Is it okay? Once your TDS is above 450 parts per million, that means it's not okay. So for the secondary treatment, there is like your aeration system. You have the sewage is further broken down. When you introduce this time around, you cannot have, you know what, when we're doing water treatment plan, we said, okay, you have the aeration system, you have natural air reacting with the water. This one, you know, it is buried. We don't use natural air per se. We use blower. We allow the blower to agitate the sewage. When it agitate the sewage, the bacteria feed on the sludge. The bacteria will feed on the sludge. From the first compartment, it will now move to the second compartment. There you will inject your chlorine to kill the bacteria further and to improve the purity level of the water. Then you also inject your lime. The lime basically is to ensure that the odor for the sewage treatment plant, the odor is taken care of. Now from there, it goes through the tertiary treatment. At the tertiary treatment, you introduce your filter vessel. It's from the filter vessel that you are now fit to discharge the water to the open drain. But at the sedimentation tank, you still have sludge settling at the bottom. So every year, every once in a year, there's need for you to what? Evacuate the sludge. Evacuate the sludge and clean the tank so that proper treatment can happen. Any question? Any question? Now, what I like doing most times after a class like this is to say, okay, you are facility managers. Is there any issues you are having with regards to plumbing system? You are free to ask questions with regards to that. Hello. Hello.
Yes, please. We're here, but we're clear on what you have.
Ask questions, general questions.
All right, sir. Like, let me mention some particular issue we're having at our place.
Okay.
At my place of work here, though we're still trying to come up with one or two options, but I also like to hear what you have to say, sir, about it so that we can resolve it. Now, this is one of our staff quarters around Surulere. Due to the nature of the soil there or the ground, it doesn't soak water, so we couldn't do a soak away there. So so what that means that what we have basically there is just septic tanks. So when I came on board, I met all around the compound we have about 5. It's not that wide anyway. There are about 5 septic tanks there already. So
wow. So how often do you evacuate?
To evacuate almost sometimes once in 3 weeks, sometimes a monthly.
So
within that range.
Just introduce sewage treatment plants for them.
Well, yes, that's one of the options we are planning to do anyway. Just like I said, that some of the things we're already in view doing, but I've not gotten let me say a good bill that to get approval for. That's one of the things that's delaying us also about that particular thing. So you feel a sewage treatment plant we are good to go.
Okay.
And I was just trying to confirm that a sewage treatment plant is the best in that kind of situation, right?
Yes, it is. I hope there are canals or open drain closer to the estate.
Well, no, canals are not that close. Yes, it's quite a distance, huh?
There's no open drain.
Yes, there are drains there too. But the drains are not. The main road, the level of the main road is higher than that of the. It's like a close. It's towards the close of the estate. That's where the building is. So it's the level of the drainage outside. There's a main road. That's what I mean. The main road itself is higher than that of the close, the estate. So anytime it rains, usually having the place a little flooded. And of course, it's not just affecting our home building; it also affects neighbors all around the place.
Okay. if there is a drain that is closed, anyway, because even if the drain is far, as long as the drain is not stagnant, if the drain is flowing, they can actually do a sewage treatment plant there. You know, the water that is coming out that will be coming out from the sewage treatment plant is treated water. Let me tell you the truth. Most of the estates you see in Abuja, the sewage water is what they actually drink, but they don't know. It's treated. The level of treatment you give to this water from the sewage, that if they tell you that water is from the sewage, you won't believe. We stopped at filtration vessel. After the filtration vessel, all you need to do is to introduce a tank, maybe a 10,000 GP tank. Then you introduce your reverse osmosis plant. It will take care of the every other thing that you need to take care of, and the water will come out very clean. Take it to your lab for analysis. Nobody will know what that you are supplying sewage water to them. They will not know because there will be no odor, no test. It will come out very clean. Some of the estates in Abuja, they don't know. Some of these hotels too, they don't know. It's the sewage water that they are recycling.
Okay. All right, sir. Thank you.
More questions?
Yeah, good evening, sir. Hello?
Can't hear you.
Good evening, sir.
Good evening.
Okay, my name is Adams. I want to ask, in the estate where I manage,
okay,
due to the nature, or let me say the topography of the area, it's not always a leveled land as at during the time of when they bought the area. Now, after the estate is being built and when they are doing the drainage, now some areas are higher than the other areas. Some are slopey while some are on the high side. Okay. Now, during the laying of the sewage pipes, because from here you said something like it's not of a high importance that we should have a very sharp slope, but a gentle slope.
Yes.
Now, most of the sewage pipes that are being laid, though from when we dug the areas, when we had this thing, when the sewage was kind of filled up and were to evacuate, we observed that the slope was just not gentle per se, because water flows, and because there is a trap, I believe sedimentation takes place. So there are some sludge that settles in that trap. So over time, it kind of builds up. And because of some waste that also residents flushes through the toilet and enters the that goes down through the manhole, those sludge also in a way traps those waste, like all those pads and what have you. And before you know, that place becomes, you now start have a sewage overflowing. But after the suction now and trying to free that area, you still notice that the water from, or the wastewater, instead of flowing down from the, as in from those manholes now straight to the STP, it returns back to where the suction is being, that is where the suction is going on. What is the actual resolution that someone can provide to that particular problem? Because it's something that happens yearly.
What our advice is that for those places that you're having that kind of issue, you can introduce a lift station where you have a lift pump.
Okay.
You have a lift pump, so it will assist in pushing, you know, whatever you have, blocking the stuff, to push it from one station to the other station that you have a better flow.
Okay. Okay, thank you, sir.
You're welcome. Another question? Any other question? Okay, in the absence of.
So is it possible to get your contact for maybe further clarifications or any other thing that we might want to share with you? Yes.
Okay.
Hello, good evening, sir.
Good evening.
Good evening. Okay. Can you hear me?
I can hear you.
Okay, sorry. Been on transit, so that's why I'm on ghost mode. It's okay. My name is James. Um, the challenge I've had from the one to date is the water heater has a hotline. If it's unused for a
Can you
period
speak
of
up a
time.
little?
Okay, can you hear me now?
Yeah, I can hear you.
Okay, I said the challenge I'm having is the hotline. That's water heater.
Water heater. Okay,
When
good.
the hotline is unused for a while, if next time you turn it on, it will come out with an odor. But the cold line, anytime you put it on, it's always good to go. But the hotline comes with odor. So I don't know what the problem is or what could be the solution. Just the hotline.
The
Like if
hotline
someone
comes out
travels.
with odor.
Yeah?
You said when the hotline is not used
It's unused for a while, for a period
for a
of
while.
time, maybe 3 weeks. Yes. Hello?
Hello. See your water treatment plants, right?
Huh?
Your water treatment plants.
Yes.
Is it the chemical type or the RO type?
It's the chemical type.
Chemical type. How is your
Yes.
water like?
Huh?
What is the quality of your water like?
Okay, the quality of the water is okay. Like you explained today, using the pH this thing
What I
to
want
check
you to
the
do,
water level.
what I want you to do is this.
Okay.
Take a sample of that water.
The hot one.
The hot water. No, not the hot water. The cold water.
Okay.
Take a sample of the cold water.
Okay.
You boil the water and leave it for
boil it.
3 days. Yes, boil it, leave it for 2-3 days. The issue is not the water heater. The issue itself is your water. Your treatment for the water is not complete. Boil the water and leave it for 2-3 days and observe it and come back to me.
Okay, sir. But we can get your contact so I can easily reach you.
Okay, my phone number is 080.
Just a minute, please. Let me check. Please.
Hold on, please.
Okay, 080
855
855
015
015
23.
23.
Yeah.
23. Okay. Let me call it again. 080 855
Yeah.
015 23.
Yes.
Okay. Mr.
Engineer Sydney.
Engineer what?
Sydney.
Sydney. Okay. Thank you very much, sir. I appreciate it.
Welcome. Yeah. Kingsley, your question.
Yes, good evening, engineer.
Good evening.
My question is, how do I increase the pressure of water that is coming from the government base?
From the government means?
Yeah. Because I
what you need
noticed
to
that
do is
when the water is coming out,
the water from the mains itself is low.
It's low, very low. It takes me 2 days to pump to fill up 1,000 liters of tank.
That one is from that side though.
Oh, it's from their own plant.
It's from their own plant.
Because when I
even if you try to introduce a pump on the line, It's what the supply that the pump will suck.
Yeah. Then secondly, I have a challenge. Yes, we have the 1 horsepower pump. You know, the one that pump the storage tank is the pump that pump the water up to the one on the roof, and then the other one distributes to the room. Now, my problem is I noticed that the pump upstairs seems to, what it does is the pressure pump bursts almost all the pipes. Yes, they were not galvanized pipes or pressure tested pipes. They were just all these normal pipes that they were used conduit, but they were run conduit. Now, I don't want to start running surface. So somebody suggested that we should get a water pump to reduce the pressure.
You see, most times the challenge is from the design stage.
Yes.
For all pipes, on the body of the pipe is written the standard pressure that a pipe can take or that a pipe can withstand. And so when you introduce, maybe you are managing a property that is occupied by expatriates or some of these Nigeria guys that are eager to have high pressure, they force you to go and get a booster pump or what you call a pressure pump.
Yes.
Without you knowing the kind of pipe that has been installed inside the wall, if it's a conduit pipe,
yes,
and the pressure that that pipe can withstand. You now install a booster system with high pressure. The next thing you start observing is leakage everywhere. So for me to solve this your problem, I will first of all ask that you ask your plumber to at least you'll be able to see the kind of pipe that has been installed in the wall.
Yes.
If
Yeah,
I know the kind of pipe that has been installed in the wall, I will be able to advise you the kind of booster system you will use. There are some booster systems that you can actually reduce the pressure.
I think it's just this PVC pipe.
Just PVC pipe?
Yes, sir.
And so, but the challenge now is this: if I ask you to install the pump without the pressure switch, you will have issue because the pump will just be running continuously without stopping. Are you experiencing that currently?
Yes, what I did was because I took off the pressure pump and then we just have the pump there, but the water is not, pressure of the water is very low. When you have three taps running at the same time, it reduces.
But that can also lead to frequent burning of the pump because the pump will just be running continuously. So what you need to do,
I have to disconnect it.
What you need to do, even when you install that pump, there are pressure switches that you can actually adjust the pressure. For UPVC pipe, the UPVC pipe can withstand minimum of 8 bar. So with a 4 bar, you are good to go. Even with 2.5 bar, is okay.
Okay.
Ask your supplier that you want a pressure switch that you can adjust the pressure. They are available in the market.
All right, sir.
So don't do more than 2.5 bar when you're adjusting it.
Okay, sir. All right. Thank you very much.
You're welcome. So I think we'll call it a day. So I'll meet you guys physically when we go for the road trip.
All right.
Hello, sir. Sorry.
Yeah, hello.
Hello, sir. Sorry, I was not there when we started, so I didn't want to disturb the lesson. Your name, sir?
Engineer Sydney.
Sorry,
Sydney as in Australia. Sydney. No, mine is spelled S-I-D-N-E-Y. S-I-D-N-E-Y.
Okay. All right. Thank you, sir.
This is your number, sir.
080 855
855
55
855
Yeah, 015
015
23.
3. All right, thank you very much.
You're welcome. Okay, thank you very much.
All right, sir. Yeah, thank you very much, sir. Bye.